All right, so looking at all 5 of these, and I just did this verbally before I hit record, you're going to have vertical asymptotes at -3 and +2 for all of them. And I left space for you to write that if you want to, but more importantly is that you just need to draw it. So if you can just dot those in at -3 and +2 for all 5 of them. It shouldn't take that long, but I started you doing it before I hit record, so you should be like done at the same time as me. So I put together this little like 5-question compare and contrast. So you can see what happens when there's 2 vertical asymptotes, because it is kind of interesting when there's 2 of them. Oh, and for all of these, I put the horizontal asymptote at 0. If you go and compare the powers, the numerator will always be smaller than the denominator. So they're all at 0. But listen, and I did mention this last time, but it was briefly, and a weekend happened. When you dot in the horizontal asymptotes, it should really just be on the edges, because it might go through it in the middle. Do you remember me bringing this up? Like, you could have something that looks like this. And if you dot it the whole way through, like, people get upset that the graph went through it. So just dot it at the edges, okay? So they're all going to be 0. And again, you can write y = 0 on the line for all of them if you want to. I left space for that. But basically, I'm just more concerned about you drawing it. I just wanted us to do a little compare and contrast. So they all have asymptotes in the same place. That's the comparison part. That's what they have in common. What I'm going to change is where they have x-intercepts. And that's what I want you to just like understand, how the graphs turn out different. Where did I put my pencil? So looking at this first one, x-intercept, you would set this equal to 0. What do you guys think? Why is it none? 2 does not equal 0. If you get 2 to equal 0, you're going to need to let me know. That's a problem. Okay. Now, when you go to draw in the graph, all of this is invisible, and we didn't get any x-intercepts. Here's how you work through that. Is you just need to find if the graph is above the x-axis or below the x-axis, because it needs to live either above or below. I call this above or below sea level. Now you can make an XY table if you want, but it doesn't need to be that picky. Give me a number that lives in this section. So something smaller than -3. -4. Watch me do, just don't look away. Watch me do this. If I plug in -4 to this factor, -4 + 3 would be negative. I don't care what it is, just that it's negative. You with me there? If I plug in -4 to this factor, -4 - 2 would also be negative. I don't care exactly what it is, just that it's negative. A negative times a negative is positive. That part of the graph is above sea level. That's all you have to do. It does not need to be picky or specific. It's just, where does it live? All right, give me a value in between -3 and 2. Let's do 0. You ready? If you plug 0 into this factor, 0 + 3, I don't care that it's 3. I care that it's positive. Good. 0 - 2, negative. A positive times a negative. Negative, it is below sea level. And then give me a number in this section. Bigger than 2. 4. 4 + 3 is positive. Good. 4 - 2, positive. Positive times a positive is positive. It's above sea level. So all you're seeing is it above or is it below? It's not hard, but you have to test each number. All right, let's try it again. If you set this equal to 0, where's your x-intercept? Because there actually will be one this time. 0. 0, x = 0. That's just 0. So you have one at the origin. Now we're going to test numbers. Stick with me because I'm just going to verbally take you through it. Give me a number in this section. -6. Now I actually need to plug into the numerator. If you put -6 in the numerator, that's, yeah, but negative is the point, right? -6 plus 3, negative. -6 minus 2, negative. You have a negative, a negative, and a negative, which would be negative below sea level. All right, give me a number in this section.
Yeah.
Well, we already have a point at zeros. -1. In the numerator, that would be negative. -1 plus 3, positive. -1 minus 2, negative. So you have a negative, a positive, and a negative. So look, that part's going to be above sea level, but you're going to go through that point, and then that will end up being below. It looks like a wiggly thing in the middle. Hold on. We plugged in a number in this section. It came out above sea level, but we have to connect to that point. So it has to go through there and go down to the other side.
Why can't it count?
So if you want to actually test that, you can plug in 1. Are you ready? Numerator would be positive. 1 plus 3, positive. 1 minus 2, positive, positive, negative. Be negative. It would be below sea level. Okay, let me go back. We're going to do it again. I need for you to all to listen and pay attention. If you got it, then just listen again. Give me a number in this section. -2. Numerator would be negative. -2 plus 3, positive. -2 minus 2, negative, positive, negative. So above sea level for that section. And then when we picked a number in here, which the only one you could really pick is 1, we got below sea level, so it's going to have to come down here. You just have to connect to that point. That point exists on the graph. The graph has to connect to it and go through it. All right, give me a number in this section. 5. Numerator is positive. 5 plus 3, positive. 5 minus 2, positive, 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 above sea level. If you set this equal to 0, what's your x-intercept? 1. Good. Go ahead and put that point there. And so if you didn't quite get it, you're going to get to see it again. Give me a number in this section, the first section. -5. All right. -5 minus 1, negative. -5 plus 3, negative. -5 minus 2, negative, 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 below sea level. All right, give me a number in this section. Yeah, oh yeah, go ahead. 0 is good. Hold on 1 second. Question.
Wouldn't it be like a negative times negative and then negative over negative?
Yeah, don't overthink it. If you have 3 negatives, it comes out negative. It doesn't really matter if it's in the numerator. That's a very valid question, but don't overthink it. Okay. All right, so 0, let's try 0. 0 minus 1, negative. 0 plus 3, positive. 0 minus 2. So you have negative, positive, negative. Or negatives cancel, it's going to be positive. So look, come with me on this. You're going to be above sea level until you get to that point, and then it's going to go below. You can check a number in this section if you want, but it's going to have to be 1.5, and I don't really feel like doing that. So can you just trust me? See how it looks exactly like that one? We're doing a compare and contrast here, so go ahead. Where is there a bounce? I don't have a bounce anywhere. No, that one doesn't touch the x-axis. It's not allowed to touch the x-axis because we had no x-intercepts. So when we got that it was below sea level, it has to stay there. There's no point here for it to go through. See how this one, this is a good question. This is what I'm trying to get you guys to understand. Do you see how this one had no x-intercept? You can't touch. Do you see how this one has one? It has to go through that point. You see how this one has one? It has to go through that point. Give me a number in this section. 8. I heard somebody say 8. 8 minus 1. Positive. 8 plus 3. 8 minus 2. Positive, 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 positive. Above sea level. So look, do you see how this one had no x-intercept? Do you see how these ones had one? Where is the x-intercept? In the middle. Where does this one have an x-intercept? If you set that equal to 0. Good. Negative 5, 0. Oh my gosh, where did it end up now?
That's where it's-
Do you see how it's not in between anymore? I'm going to start out over here. We'll start on the easier side. Give me a number in this section. 5. 5 plus 5. Positive. 5 plus 3. 5 minus 2. Positive. Above sea level. Now, when we do the part in the middle, do you see how it will not touch the x-axis? So it will either stay above or it will stay below. It can't cross through. Do you see how there's not a point here for it to go through? All right. Give me a number in this section. Can we do 0? If 0 is an option, pick 0, okay? 0 plus 5. Positive. 0 plus 3. Positive. 0 minus 2. Negative. A positive, and a negative. Negative below sea level. It has to stay there though, because why? There's not a point for it to go through. Now, I can't ask you for a point in this section. This is really the only number that we have that we can try. So what is that? Negative 4. Let's try negative 4. Negative 4 plus 5. Good. Negative 4 plus 3. Negative. Negative 4 minus 2. Negative. So good. Positive, negative, negative would be positive. Can you watch so I don't lose everybody this time? You're going to start above sea level and it's going to go through. But do you see how it has to level off at 0 over here? So there's going to end up being this little bump and it has to come back and level off because it has to level off at 0. Now that bump is super, super, super tiny. It's like the tiniest little decimal. I greatly exaggerated it so that you could see it. No one asked me anything. I want to do the next one because we got off track on the other side of the paper. All right. I just want you to compare and contrast. If you set this one equal to 0, what's your x-intercept? 6. Do you see how that is not in between the asymptotes? You're going to end up with like a little bump. Let's do our above and below. Give me a number in this section. Negative 6. Negative 6 minus 6. Negative. Negative 6 plus 3. Negative. Negative 6 minus 2. Negative. Negative, negative, negative. Below sea level. Give me a number in the middle. 0. Now, do you understand that it can't cross through? It's going to stay above or stay below. 0 minus 6. Negative. 0 plus 3. Positive. 0 minus 2. So negative, positive, negative. Good. Negatives cancel above sea level. And then you need to give me a number that's somewhere in here. So like one of these. 5 is good. 3 would be good too. It really doesn't matter. 3, 4, or 5. Whatever. Let's go with 5. 5 minus 6. Negative. 5 plus 3. Positive. 5 minus 2. Positive. So negative, positive, positive. Now watch. You're going to start out below sea level. You have to go through that point. But then what does it have to do? It has to come back to 0. It has to level off at 0. So you're going to end up with like a little bump there. So here's the takeaway. If the graph has 2 vertical asymptotes, and this only ever happens if you have 2 of them, and the x-intercept is outside of them. If it's in between, everything's good. It's just going to go through it and you get a little wiggly thing. But if it's outside of them, then there is a bump. I'm just calling it a bump. That's not like a real technical term, but if you have a better suggestion, I'd love to hear it. There is a bump. And then it's going to come back and level off at wherever the asymptote is. I think I will be able to do both 8 and 9. And I think we need to because that was a little shakier than I wanted. So we're going to go back. We'll do 8 and 9. I should be able to get that done before 10 and you'll have at least 20 minutes to work on your delts math. Okay. So go back to number 8. We'll do 8 and 9. Hang in there. You're going to be good. We'll do 2 more together and then the rest of the time will be yours. So what is the denominator going to split into? Good. Perfect. Who are your troublemakers? 2 and -2. You have to skip over the -1 first. What can they become now that we've booted them out? Why can't they be wholes? Nothing canceled. That means you have 2 vertical asymptotes, -2 and +2. So when you have 2 of them, what it's going to look like is based on where that x-intercept is. If you have one at all, or if it's in between them, or if it's outside of them. So that it all hinges on that x-intercept. All right, horizontal or slant asymptote, compare your powers. This is x to the first, this is x to the second. So what do you think? 0, good. And just dotted at the edges, it's hard to see anyway because it's on the axis, but it might go through in the middle, we'll see. Lots of weird stuff can happen. All right, so here's what this all hinges on. Where's our x-intercept? If you set this thing equal to 0, -1. So, hey guys, is that in between or on the outside of the asymptotes? It's in between. So what you're going to do is get a wiggly thing in the middle. You will not end up with that little bump. All right, y-intercept. We're going to plug in 0. You can plug into the factored one or the original. I sometimes think the original is easier. If these x's are 0, what do you get? Yeah, -1/4. So, oh, hey, look. 0, -1/4 would be right about there. So I know it's going to have to wiggle like this because I have to connect to both of those points. So actually we got the middle part already. So you have to go through both the points. Like it all has to connect. You can't just leave it floating out in space. So we just need to test these two, see if it's above or below. So can you give me a number in this section? -5. -5 plus 1. Negative. -5 plus 2. Negative. And then that would also be negative. So negative, which means below. And based on our common sense with everything else that has happened, where's this one going to be? Positive. Good. What's your range? Yeah, everything. Good. Nothing got left out. If you sweep downwards to upwards, it's going to be everything. If you go left to right, is it increasing or decreasing? Decreasing. So you're going to copy over. I feel like once you get it drawn, all the leftover characteristics are super easy because you can just look at it. Like, oh, there's the answer. I can just see it. And then the ends, and it'll take us a second to write it, but where are both ends leveling off? What number? 0. Everything goes awesome in this class because you guys just listen and everyone talks to me and pay attention. It's fantastic. So you will have plenty of time here at the end. I had an error on my other paper. All right, one more. Number 9. We're going to need to factor the denominator. So draw your 2 parentheses. And then think about how 8 is going to split up. Good. It'll be +4 minus 2. And this trips people up because people really, really, really want something to cancel. And it's like so close. But x minus 4 and x plus 4 don't cancel. They're not the exact same. So nothing cancels. You won't get any holes. You can't make it be true. You just have to take what you get. All right, so who are your troublemakers? Who are we kicking out? Yep, negative, you guys have got that. I feel like getting the domain, like if you can get that, like the rest of it kind of falls into place. Because once you have those two numbers, everything else sort of hinges on those two numbers. Now, since there aren't any holes, that means they are both vertical asymptotes. And what it's going to look like is going to depend on where the x-intercept is. If the x-intercept is in between them, you'll get like a wiggly thing. If it's outside of them, you'll get that extra little bump thingy. Which is, again, a very technical mathematical term. Well, a little bump. I don't know. What else would you call it? That's what it's like, a little bump, and then it has to level off. All right, so if you set this equal to 0, what's your x-intercept? 4, good. So is that inside the asymptotes or outside? Outside. You're going to get a little bump. Y-intercept, if you plug in 0, and again, you can plug it into the factored version or the original version. I sometimes think the original one's easier. You can just cover up the x's. You're left with -4 over -8, which would be 1/2. So actually, we have the middle part. If you have to go through that point and you can't touch the x-axis anywhere else, it's going to have to do this. You can't touch the x-axis anywhere else in between there. So it has to go through that point and stay above sea level. Oh, I totally skipped this. I'm sorry. I usually do that next. What is your horizontal or slant asymptote? Which one do we have? Yeah, it's going to be horizontal and it'll be 0. All right, and then let's pick numbers to test. Can you give me a number in this section? -8, good. -8 minus 4. Negative. -8 plus 4. Negative. -8 minus 2. Negative. Negative, negative, negative. Below sea level. And then can your common sense kick in? Look, if this one looks like this one's going to kind of look like that too. It's just you have to go through that point. It's going to go through that point and then make like a little bump. It has to come back and level off at 0. I'm just trying to save you some time and energy. If you can let your common sense kick in and be like, oh, it's going to be like sort of symmetric, you know, it saves you some time. All right, and then some of you probably wrote this already. Where do both of these level off? I think somebody said it back there. Yeah, 0. I'm going to say this on the recording. We will do a quiz next time on this because we've now officially spent 2 whole blocks doing nothing but practice rational graphs. The one that your quiz is on will follow this pretty much exactly. Because you know how these graphs can turn out really weird a bunch of different ways? The way that your quiz turns out is just like this one. So I'm going to stop the video. I'm going to fill this out and take a picture of it and post it. So if you want to do this one for next time, your quiz will follow just like that. Like this is your quiz review if you want to think of it that way.